Assalamu alaikum. Welcome to my thesis presentation. I am A.K.M. Sifat presenting this thesis. My supervisor name is Muhammad Mominul Haq. My thesis topic is application of the dynamic cone penetrometer for determination of index and engineering properties of sandy soil. From the thesis title, we can see I introduced dynamic cone penetrometer to determination index and engineering properties. For index properties, I choose relative density and unit weight of the soil, and for engineering properties, I choose angle of internal friction of sandy soil. Here is outlines. I'm gonna discuss about background study, objectives, laboratory investigation, result and discussion, conclusion, limitation and further recommendation. Background study. Background study based on bearing capacity of shallow foundation for lighter structure. Bearing capacity depends on two major phenomena, that is relative density and water table. In our country, we commonly use standard penetration test to determination of bearing capacity. Here identification of some problem doing standard penetration test, that is ability, installation, rules and regulation problem. It also expensive and it always skilled people needed. On the other hand, the dynamic cone penetrometer is simple, easy to operate, easy to application, lightweight and it's inexpensive. Objective of the study. The objective of the study is to develop relationship with relative density and unit weight, that is soil index properties, and the angle of internal friction, that is soil engineering properties, by using dynamic cone penetrometer. Here is the laboratory investigation, that is soil sample prepared, grain size analysis and specific gravity, Proctor compaction test, optimum moisture content, mold and sample orientation, dynamic cone penetration test, and direct shear test. For the thesis, soil sample collected from three river sand, that is Padma, Meghna and Brahmaputra. Here is the grain size analysis of three river sand. The blue one is Padma river sand, the red line is Brahmaputra river sand, and green line is Meghna river sand. The horizontal axis represent particle size and vertical axis represent percent finer. Now we can see the result of grain size analysis for three river sand, Padma, Meghna and Brahmaputra. We have value of fine modulus, soil particle size D60, D50, D10, and also we have coefficient of curvature and coefficient of uniformity. For further experiment, I choose Meghna sand value because the value is quite nearby Padma sand and Brahmaputra sands. From ASTM texture classification, I found Meghna sand is poorly graded sand and its specific gravity 2.7. The Proctor compaction test gave me the maximum and minimum unit weight of the soil sample. I found minimum unit weight, that is 12.88 kilonewton per meter cube, and maximum unit weight, that is 15.81 kilonewton per meter cube. To find minimum unit weight, the soil sample was loosely compacted, and for maximum unit weight, I used trial and error method. Here is the graph of compaction test. There is two lines. The top line represents zero air void curve and the bottom line represents compaction curve. The horizontal axis represents moisture content and vertical axis represents dry unit weight. From that test, I found at 10% moisture content, the dry unit weight is maximum. So the optimum moisture content is 10%. For further research, I choose 10% moisture content. This is the mold I use for this research. The height of the mold is 304 mm and the diameter of the mold is 152 mm. The top and bottom layer, that is 76 mm, are not countable for soil confinedness, and the medial 152 mm is countable for DCP penetration. The soil sample was pouring into the mold by using weight volume relationship method at stage of 30 to 100% relative density. The sample was compacted equally and manually by using hammer. This is the image of dynamic cone penetrometer. It have a handle, a hammer that is 8 kg, anvil, tip and a cone. The cone was 60 degree. Now I represent the result of dynamic cone penetration test. The horizontal axis represent the DCVT blow numbers and the vertical axis represent the penetration depth. For this experiment, I applied the dynamic cone penetrometer at different stages of relative density, that is 30% to 100%. At 30% relative density, I found 5 number of DCVT blow to reach the penetration depth, that is 152 mm. At 40% relative density, I found 6 number of DCVT blow. At 50%, I found 7 number of DCVT blow. At 60%, I have 8, 70% I have 9, 80% I have 10, and 90% I have 11, and the 100% relative density, I have 12 number of DCVT blow to reach the penetration depth, that is 152 mm. From that experiment, I find a soil index property. So I can easily correlate the value of the dynamic cone penetrometer blow and the relative density. Here is the graph. The horizontal axis represent number of DCVT blow and the vertical axis represent relative density. I got an equation, also a coefficient of determination r square equal to 1. So from that equation, if I know the number of DCVT blow, so I can easily find the relative density. Here is the second index property, that is unit weight of the soil. From that experiment, we also can correlate the number of DCVT blow with the unit weight of soil. Here is the graph. The horizontal axis represent the number of DCVT blow and the vertical axis represent the unit of weight of the soil. We also have an equation and the coefficient of determination r square equal to 0.9982. Now I represent the result of direct shear test to find the engineering property, that is angle of internal friction. The normal force I applied 5 kg, 10 kg and 20 kg at different relative density, that is 30 to 100. Here is the table. The right side I have angle of internal friction, that is phi, and left side I have relative density, that is 30 to 100. From that experiment, I can also correlate the number of DCVT blow and the angle of internal friction. Here is the graph. The horizontal axis represent number of DCVT blow and the vertical axis represent the angle of internal friction. I found an equation. If I have number of DCVT blow, I can easily find the angle of internal friction. Here is a table that represent the overall result of this thesis. I have number of DCVT blow. I have two index property, that is relative density and unit weight. I have engineering property, that is angle of internal friction. From that result, if I have the DCVT number of blow, I can easily find the engineering and index property. In here, I try to compare my research result with two another research paper, that is Myrov and Mohammadi. The horizontal axis represent relative density and the vertical axis represent angle of friction. I got three equation and a coefficient of determination. If I focus on coefficient of determination, that is almost same. That means the slope is quite similar. And if I focus on y value, there is some difference because of some limitation. From that research, I conclude dynamic cone penetration blow can find sandy soils index property, that is relative density and unit weight, also find engineering property, that is angle of internal friction. Here is some limitation. I use poorly graded sand for this experiment. There is laboratory test, so there is no field test can be applicable. I made the relative density by using weight volume relationship method. Here is further recommendation. We can use clay soil, we can do also field test, and we can do footing design.